Alrighty, 3.3, special factorization tricks. In 3.2, we did special expansion tricks. This is something called factorization. But the first thing you'll notice on this page are these. The three rules that we learned in 3.2. They're actually called identities in math, and an identity is something that is always true. We're going to just practice expanding with these, just like we did in section 3.2. So there's three problems to practice expanding. I'll do these by following the rule, but you should pause and do them yourself. Alright, so when this is done, I do want you to notice that there are some square numbers that appear. The first term and last term of each of these are square numbers. Both of these terms are square numbers, 25, x squared, and 49. They're all square numbers. And recognizing square numbers is what is useful for this topic. Factorization is the opposite of expansion, and you've done it before. The type of factorization that you've done is something called common factoring. So if I have a question that is 2x plus x, we are able to find something that is common between those two terms, in this case x. We're able to find what's common, and we're able to factor it out. And when I say factor it out, it usually means we're going to draw some brackets and put the x on the outside of the brackets. We have factored it out. But when you factor, you're actually doing some division in your head. The first thing you're doing is whatever 2x divided by x is needs to go in this spot right there. So 2x divided by x, that's 2. And x divided by x, that's 1. And this is a weird problem because you could have just collected like terms and came to the 3x answer the same way, but it's fine. All we need is an example of something that is factorized. We factorize by finding stuff that is common. In general, we want to make brackets. This is opposite of what we've done before. We've done lots of expanding, but we haven't really tried to make brackets this year. We're going to try to do that. Again, another problem, x squared minus 2x. Common factoring, we find something that's common. Again, it's x. We take it out and we divide to find out what's left over. In this case, x minus 2. The result is something that's pretty clean looking. Most math people would think that this is more simple than that, and I kind of agree. The first kind of factorizing we're doing is factorizing using the identities that are here. If it's helpful for you, just write them down. Every opportunity you get, just write them out so you can memorize them. But I'm going to try to factorize some stuff by using those identities. Out of those identities, there's only one of them that has two terms in the expansion. It was called the difference of squares. So I'm going to notice that this one kind of looks like a squared minus b squared. I get that because first term is a square number, 9x squared, second term, a square number, it's 25. And I know that a squared minus b squared is equal to a plus b, a minus b. So I'm going to apply that to this, and as a result, I will be factorizing it. I'll just draw my little cloud over here. A is 9x, or sorry, a squared is 9x squared, and b squared is 25. So then your job is to find out what is a and what is b. The same thing pretty much for these three practice problems. You can try to do it on your own, or you can follow along with me. I'm going to talk my way through it, so either pause the video or just listen along with me. Okay, so first one, a squared was 9x squared, b squared was 25. I'll quickly do some math and conclude that a is 3x and b is 5. The operation that I did to go from cloud number 1 to cloud number 2 was a square root. Did a square root of these terms, and I ended up with an answer. So now just look over to my cloud and copy some terms. Second question, again, some terms with a and b. I'm going to look at the first term and the last term because I recognize this as a squared plus 2ab plus b squared. So let me do some work. A should be equal to the square root of 25x squared. B should be equal to the square root of 1. This is 5x, and this is 1. Awesome. Because I know the expansion for this is a plus b squared. Okay. So because it's a plus b squared, I'll look over here, and I'll use a and b. Doesn't seem too tough. 5x plus 1 squared. Okay, this is weird because I'm not really doing too much math, but I'm getting an answer. The only math I'm doing is memorizing some rules and then using square root, which is not a crazy hard thing. The square root of 25, that's not too stressful. Let's try another one down here. I need to find a and b. I should recognize what one of the identities I'm using. In this case, it's a squared minus 2ab plus b squared. I was able to tell that very easily because there's 3 terms and this one is negative. So I'm using my, really, you could be scrolling back and forth between your, oh wait, scrolling? You're on paper. Anyways, you could flip back and forth between the first page and this page and look at those identities just to get the idea. But they are different in very significant ways. This one has 2 terms. This one is all positive. This one has 1 negative. So they're different. A is going to be equal to the first term square rooted. B equal to the last term square rooted. And that's what those are. So throw those terms into a bracket, put a minus in between them, and you're done. Right. So this section, a lot of memorization, and that's about it. There are some other tools that are going to be useful for you. The most important tool is that you're able to common factor. There are some problems in the work for this chapter that when you look at them, they will not look like an identity, but if you common factor, then they will look like an identity. And that is all. All right, that's chapter 3.